Okay, hello Cloud Gurus and welcome to this lecture. In this lecture we're going to look at SQS. Now SQS is the oldest service in AWS. It was one of the very first, if not the first service with AWS. And for that reason it comes up an awful lot in the Solutions Architect Associate exam. So you might be wondering, what is SQS? Well, it's a web service that gives you access to a message queue that can be used to store messages while waiting for a computer to process them. It's a distributed queue system that enables web service applications to quickly and reliably queue messages that one component in the application generates to be consumed by another component. So that's all SQS is. It's a way of storing messages in a queue. We're going to have a look at a couple of examples so it all makes sense. So let's start with a meme website. If you want to make a meme, you have your user, you might go over to memegenerator.com. And essentially what you're going to do is you're going to upload a photo. And here's the A Cloud Guru team in Melbourne. So let's say I upload a photo to S3. And then what's going to happen then is that's going to trigger a lambda function. Now, we will cover off lambda functions in the next section of the course, but essentially a lambda function is just a little bit of code that sits out in the cloud and it does something when triggered. So this lambda function might take that S3 image, and what it might do is it might say, hey, we're going to write a bit of text over this image, and the text is as follows, and it will store that text in SQS. So SQS has that text, and it might be something like hello Cloud Gurus. And then what will happen is you've got an EC2 instance, or this could be a fleet of EC2 instances behind an auto-scaling group. And what those EC2 instances will do is they'll poll the message queue and they'll look for work. And essentially, they'll intercept that message, and what they'll do is they will create a meme. So it will be hello Cloud Gurus, and then it will go and store that meme on into an S3 bucket. Now, the cool thing about this is if we lose an EC2 instance while it's trying to create this meme, what will happen is the message will become available again in the queue, and another EC2 instance will be able to go in and then create that meme. So you don't lose any information. So SQS is a way of storing messages independently so that even if an EC2 instance is lost and can no longer process that message, then another EC2 instance will come along and take that message. So that's all that SQS is. Let's have a look at another example. So we've got a travel website. Let's say it's Expedia or Skyscanner. Big shout out to everyone at those companies. I use them a lot. So we've got our user and they want to go and get some deals on flights or maybe on hotels. And so what they do is they go over to an EC2 web server and they say, hey, I want to go to Rome on these dates. The EC2 web server then passes that information to an SQS queue. And then what will happen is we've got some application servers in the background, and we'll have a whole fleet of them, each configured to go and get that message and look for different airlines. So it might be Delta, it might be British Airways, it might be United, etc., etc. And it's getting the best flights and hotels for that date. That is then collected by the EC2 instances. It's passed back to the web server, which is then passed back to our end user. And the cool thing again is if we lose an individual EC2 instance, we won't lose that information. Another one will come along, poll the queue, and return that result back to the user. So using Amazon SQS, you can decouple the components of an application so they run independently, easing message management between components. Now, I want you to notice that word decouple. If you ever see a phrase decouple in the exam, I want you to think straight away SQS, because that's the language they've been using for years. If you want to find a way to decouple your infrastructure or decouple your microservices, think straight away SQS. So any component of a distributed application can store messages in a fail-safe queue using SQS. And messages can contain up to 256 kilobytes of text in any format, and any component can later retrieve the messages programmatically using the Amazon SQS API. Now that 256, you can actually go above that. It's not stored, the information won't be stored in SQS, it'll actually be stored in S3, but you can go up to, I think it's like 2 gigs in size right now. It does change quite a bit. But just bear that in mind as well. The 256 is not a hard limit. You can go above it. But it won't be stored in SQS, it will be stored in S3. So the queue acts as a buffer between components producing and saving data, and the component receiving the data for processing. This means that the queue resolves issues that arise if the producer is producing work faster than the consumer can process it, or if the producer and consumer are only intermittently connected to the network. So it's a way of spacing everything out. So there's two types of queues. We've got our standard queues, which is what happens when we create a queue by default. And then we have our FIFO queues, our first in, first out queues. So standard queues are this default queue type. A standard queue lets you have nearly unlimited number of transactions per second. Standard queues guarantee that a message is delivered at least once. And occasionally, because of the highly distributed architecture that allows the high throughput, more than one copy of the message might be delivered, and it might be delivered out of order. However, standard queues provide the best effort ordering, which ensures that messages are generally delivered in the same order that they're sent. But just remember that that is not guaranteed with standard queues. So your application needs to be able to cope with two things. One of them, the messages being delivered out of order, and the second one, multiple copies of the same message being delivered twice. If your application can't cope with that, then we need to look at FIFO queues. So FIFO queues complements the standard queue. FIFO is essentially first in, first out. And the most important feature of this queue type are FIFO, so first in, first out delivery, and exactly once processing. So the order in which the messages are sent and received is strictly preserved, and a message is delivered once and remains available until a consumer processes and deletes it. Duplicates are not introduced into the queue. So again, you're going to get a whole bunch of different scenario questions, and they'll say, hey, your application needs to have this, it needs to be in sequence, and we can't cope with more than once, the message being delivered more than once. Then, of course, you're going to use FIFO queue. If your application can cope with the message being sent more than once, and it doesn't care about the order of messages, then you want to use a standard queue, and that's where it's going to come up in the exam the most. FIFO queues also support message groups that allow multiple ordered message groups within a single queue. FIFO queues are limited to 300 transactions per second, but have all the capabilities of standard queues. So because of the nature of FIFO queues, they're not as fast as standard queues. They are limited to 300 transactions per second, so do bear that in mind. So going on to my exam tips. So just remember that SQS is pull-based, it's not push-based. So you have to have an EC2 instance pulling the messages out of the queue. We're going to look at SNS a little bit later, which is push-based, and that's kind of the opposite. But right now with SQS, it's pull-based. So you have to have EC2 instances polling the queue, pulling those messages out of the queue. Messages are 256 kilobytes in size or less. Messages can be kept in the queue from 1 minute to 14 days, and the default retention period is 4 days. Moving on to visibility timeout. So visibility timeout is the amount of time that the messages is invisible in the SQS queue after a reader picks up that message. So again, imagine that you're creating a meme, you've added the text into the SQS queue saying like, hello cloud gurus, and then the EC2 instance picks it up and it's got to write that text to the image. The visibility timeout is just the length of time that that message is now going to be invisible in the queue until that EC2 instance has processed the job. Now, provided the job is processed before the visibility timeout expires, then the message will be deleted from the queue. However, if the job is not processed within that time, then the message will become visible again and another reader will process it. And this could result in the same message being delivered twice. So again, a very popular exam question is, you're getting the same message being delivered twice. What could be the cause of this? Well, your visibility timeout is not long enough. Essentially, the job is taking longer than the amount of time that you've made this message invisible in the queue. So what do? Well, you increase the visibility timeout, a very popular exam topic. Visibility timeout maximum is 12 hours. So bear that in mind as well. You must have your job processed within 12 hours. Otherwise, it will become visible back in the queue as well. Moving on, SQS guarantees that your messages will be processed at least once. Amazon SQS long polling is a way to retrieve messages from your SQS queues, while the regular short polling returns immediately, even if the message queues being polled is empty. Long polling doesn't return a response until messages arrive in the message queue or the long poll times out. So this could be, again, a very popular exam question. Essentially, you've got a queue that's mostly empty, and you've got your EC2 instances that is always just polling the queue over and over again, saying, hey, I want more work, I don't have anything to do, but your SQS queue is empty. And that basically essentially costs you money, because every time your EC2 instance goes and polls the queue, it incurs a charge. how can you reduce your bill? Well, you just do long polling, and long polling will essentially won't return a response until a message arrives in the queue or until the long poll times out. And finally, I would just say any scenario-based question where you see the term decoupling your infrastructure, so whether it's decoupling microservices or decoupling monolithic architectures, I want you to think straight away, hey, that's an SQS terminology. So look for SQS as a means to solve that issue. So that is it for this lecture, everyone. If you have any questions, please let me know. If not, feel free to move on to the next lecture. Thank you.